Good evening, students. So today we'll do the CBSE questions from chapter 1. Okay. So the first question is that plot a graph showing the variation of Coulomb's force versus r square, where r is the distance between the two charges of each pair. So we have one pair and another. We have two pair of charges. And we have to plot a graph showing the variation of Coulomb's force versus 1 by r square. So what is the formula of the Coulomb's force? The magnitude is given by K Q1 Q2 by r square. Now we have to, so F is equals to, we can write it as K Q1 Q2 into 1 by r square. This is the same thing. So if I write this F as y, then this will be my slope, and this is my x plus cy intercept, which is 0 in this case. So now let us plot the graph. So whose slope will be more? So the slope of this one will be k into 1 into 2. So 2k. K is equals to 1 upon 4 pi epsilon naught. So k is Coulomb's constant. So put k q1 q2 is your slope. So on this axis we have, on the x-axis we are plotting 1 by r square, and on the y-axis we are plotting a force. So force is your y on y-axis, on x-axis it's 1 by r square, and this is your slope. So y is equal to mx plus c is the standard equation. C is equals to 0 here. So now whose slope is more? So the slope of this is 2k, 2 multiply 1 into k, and the slope of this is 2 multiply 3 into 6, so 6k. So 6k has more slope. So this is for the force between 1 microcoulomb and 2 microcoulomb, and obviously the product force depends on the product of the, so the product is 6k, so this is the force on 6k. So this force is so what kind of force is it? Now these are like charges, so this is repulsive force. So you need to write here repulsive force, and this is a attractive force. Now students, if you say, sir, I want to draw different diagram for both the pairs, so then here so if this is positive force, attractive force, so for attractive force you have this for this pair, attractive, and for repulsive, so force will be negative. So here you are actually using the formula F is equals to K Q1 Q2 by r square. So you are considering the sign also here. So here the sign will be positive, so positive F, and here in this case for 2 Coulomb and minus 3 Coulomb, so the product will be negative. So negative, so it means attractive. So negative means attractive force. So this is the graph for. So this was the graph for repulsive force 1 and 2, 1 multiplied 2 positive. So this is the graph for repulsive force, and this is the graph for attractive force. So either make this diagram or make these two diagrams. So that's the same thing. Now the next question can be asked in the exam is, why do electrostatic field lines do not form closed loops? Why they do not form closed loops? So, second question, electrostatic field lines, they do not form closed loops because they do not form closed loop because they start from positive and they end at a negative charge. Or if there is only charge, then they start from positive and they end at infinity. Because they start, and if there is negative charge, then from infinity, they start from infinity and end at negative. So they start from positive and end at negative if there is this dipole. Because they start from. So, but here the question is closed loops. So this was the question that we are talking about when we are considering the loop, this one. So they start from positive charge. Why they don't form? Because they start from positive charge and they end at negative charge. Okay. Sir, is there another way? Yes, you can write that electric field is conservative in nature, or electric field is conservative in nature. So that's also the same thing. Next point, next question that is very frequently asked is, why electric field lines never cross each other? Because at the point of intersection, there will be two directions for the electric field, and that is not acceptable. So if the cross, so these are the two field lines cross. So for this field line, this will be the direction of electric field, tangent to it, and if you draw a tangent on this field line, this will be the direction. So two directions of E are not possible at intersecting point. So therefore the field lines do not cross each other. So students, note down these questions, very important questions from board point of view. Now the next question is that you have a point charge which is plus Q. Okay, let me show that question on the board. So a point charge plus Q is kept in the vicinity of uncharged conducting plate. So you have to sketch the electric field lines between the charge and the plate. So suppose this is the uncharged plate and you have placed plus Q charge. So this plate is uncharged. So as you place plus Q charge, the negative charge will appear on this side of the plate. So field lines will start from positive and end at a negative charge. So these will be the field lines that we get. So now we have another question. So in this question is related with the electric flux. So what is electric flux? What are its units? And if electric field is given to you, then how will you find the flux due to the electric field? So students, what is the definition of electric flux? So electric flux through an elemental area delta S is equal to the dot product of E and delta S. So delta phi is equals to E dot delta S. And further, if you would like to write the definition, you can also write it as phi equals to E dot ds. That is also acceptable. Another definition, if you write, okay, so through the closed surface, through the closed Gaussian surface, let's see those. So all these definitions are acceptable. Even if it is a plate, then E dot A. If there is same angle throughout, if you are taking a case of plate, then this formula will also work. Or if for the spherical surface you are taking, then also this formula will also work. So all these are definitions. So what is the flux due to electric field? So this is the electric field given to you through a square 10 centimeter. Okay, one next part is what are the SI units? So SI units are, so what is the SI unit of electric field? So electric field, so F is equals to Q into E, and electric field is equals to F upon Q. So volt per coulomb, and the units of area is meter square. So units of force is Newton. So Newton per coulomb into meter square. So these are the units of flux. And you can, now we have this numerical, and so what is the flux due to electric field to the square of side 10 centimeter when it is held normal to E? So normal to E, I have held a square whose side is 10 centimeters. So this is square. So normal to E means the direction of this square and direction of electric field is same, means theta equals to 0 degree. So phi is equals to, so we'll be using this formula here, because with all the area elements, the angle between E and all the small area element is same here. So now what is electric field? 3 into 10 raised to power 3, because it is telling that it is in the direction of I cap, means x direction. So that's what, so this is x direction. And area is equals to 10 centimeter to 10 centimeter. So area we need to write it, change it into SI units. So that is 0.1 meter. So 0.1 meter into 0.1 meter into cos 0. So cos 0 is 1. So 10 raised to power minus 1, 10 raised to power minus 1, 10 raised to power 3. So here we 10 raised to power 1. So that is equals to 30 Newton per Coulomb meter square. So students, we also have a question in NCERT where we have so this was based on a definition. Now we have a question in NCERT where we have this square. We have a square and a charge Q is placed at a distance of 5 centimeters from the sphere. Now what is the flux through this sphere? So in this question, electric field was given to you. Here the charge is given to you. So whenever charge is given to you, you have to use Gauss Law. And Gauss Law says the flux through the surface is charge enclosed by epsilon naught. So whenever you are dealing with charge, it is always charge enclosed. And here the electric field. So this thing you need to understand, that in the question you have charge or you have electric field. When it is charge, then this is the charge enclosed. So you need to enclose this charge. So in which symmetrical surface we can enclose it? So that is cube. We can enclose it in this charge in the cube only. And now this is 5 centimeter from all the sides. It is 5. So flux through all the 6 surfaces will be same. So this total flux is actually 6 multiply the flux through each surface, each square. So this is the flux through the whole surface, Gaussian surface. So Gaussian surface we have taken cube here, and that is equals to this. So students, you need to be careful what is asked in the exams. So here phi square is equals to 1 by 6 into total flux through the surface area. So this question was also there in the sample question paper 2019, this as objective question, and this can also be written as is equals to 1 by 6 Q enclosed upon epsilon naught. So 6 here also 1 by 6 and here also 1 by 6, that is the flux through the square. So students, these are two very important concepts. You are dealing with the electric field and flux, or you are dealing with charge and flux. So just be careful, and these are the only two formulas that you will be using. Now we can have questions about electric dipole moment. So if the question is define electric dipole moment, so simply you can write that electric dipole moment is the numerical product of charge and the distance between the charges, and it is directed from positive to negative charge. So this positive charge, this negative charge, so from positive to negative. So it is from it is from negative to positive. So the dipole moment is always from field lines start from positive and reach at negative. So this is the direction of field lines, and electric dipole moment is opposite to its student. So this is another way of remembering them. So this is the direction of electric field line due to means field lines start from positive and end at negative. But dipole moment, it starts from negative charge and towards the positive. So the direction is from negative charge to positive. So opposite to electric field lines. So this is also a vector quantity, and its magnitude is given by, so these charges are equal and opposite. So magnitude of one of the charges and the distance between them. So the distance between them we take as a 2a. So 2a. So that is what dipole moment is. So students, just be careful about the direction opposite to the direction of the electric field. And further, if you would like to write it in vector form, then make this vector A. So this is vector A. So P equals to Q into 2 vector. This also, you can write the direction. So this is the direction of vector A. So this is vector A actually up to here. And this is twice of vector A. So we can have questions regarding the electric field at a point on the equatorial line, that we have already done, and on the axial also, that is already there. Now the question can be asked about the graph between E versus R. So we can have a E versus R, electric field due to dipole. So students, E versus R, you know that electric field due to the dipole is it reduces by 1 by cube. So that will be the graph for the electric field and the displacement, because here the electric field is proportional to 1 inversely proportional to R cube in case of dipole, whether it is on the axial or on the equatorial. On the axis means on the axis, the point anywhere on the axis, or point anywhere on the equatorial plane. So in both the cases, E is inversely proportional to R cube. Whereas when we talk about in terms of forces, so that is force between these two charges are distance apart. So Coulomb force is K Q1 Q2 by R square. So here the force is inversely proportional to R square. So this is inverse square law. But this is here the electric field is the magnitude of electric field is decreased more quicker as compared to the force. So this graph can be there. So this is the graph between for the graph when E is or the value on the y-axis is inversely proportional to the q. So draw this diagram, this is very important. Now we can have a question about the stable and unstable equilibrium that we will be doing in the next chapter, and there can be question about the non-uniform field. So that thing I have already discussed in the videos, so please look at the videos. We want to do the, if you are unaware of when in case of non-uniform field, when the field is increasing and it is parallel or anti-parallel to the force, to the dipole moment. So that is there in your book, very important question. And some of the time you need to derive the formula torque is equal to P cross E, that is also there in your book. So now there can be 1 marker questions. So what are these 1 mark questions? Because lot of objective questions will be there. So one of the objective question is, so you have a cube, and in this cube you have placed dipole. So dipole means plus q and minus q. So what is the flux through the surface of this cube? So flux through the surface, and when the charges are given, so Gauss Law, charge enclosed upon epsilon naught. So what is the net charge enclosed? So net charge enclosed here is plus q minus q upon epsilon, that is 0. So net charge enclosed is 0. So flux through the surface is 0. So that is important point. And suppose you have a question similar to this type, that you have a surface and there is charge plus 2q and minus 3q and plus q, and here you have a charge plus 3q. So you have this charge configuration. So what is the flux through the surface? So flux through the surface, when you are dealing with charges, so charge enclosed again by epsilon naught, charge enclosed is 2q plus 2q minus 3q plus q upon epsilon naught, that's equals to 0. So again this is 0. So now, sir, what about this plus 3 cube? Okay, beta, this plus 3 cube, the field lines will pass through it. So number of field lines entering are the number of field lines leaving. So there will be no impact of the charge outside the surface. So this is the closed surface, so only the charges inside the closed surface will be considered charges enclosed. Outside have no effect on the flux. So these kind of questions will be asked in exams, and then you have the examples of the flux. So that way questions will be asked more or less like this. And let us do one simple numerical, because objective type questions, lots and lots of objective type questions will be there this time. So let us do a question which involves electric field through a region and this electric field is non-uniform. So let us look at this question. So electric field is given to you in this region and electric field is given by E equals to 2 xi. So means it is varying with the position and it is in the x direction. So this direction of electric field and its magnitude is 2x. So it is varying. लाइव है यहाँ पे 30.51 सेकंड.
क्यों नहीं आ रही?
पैसे पूछो पैसे.
पैसे सो रहा है.
So students, here you have the variable non-uniform field and you have to find the net flux through the cube and you also need to tell the charge enclosed through it. So you have the formula related with flux and E is, so flux through the surface E dot dx. So flux through the closed surface E dot ds. So try to do this question. So students, now the flux is equal to E dot ds and all this through the closed surface. So how many surfaces we have? 6 surfaces. So there is no electric field through in the y direction, negative y direction or z direction and in the negative direction, z direction. Electric field is only in the x direction. So that is direction of electric field only through the to the faces along the x-axis. So only through face 1 and 2. For rest of the faces, so it is 0. So this will be, suppose this is right side face, this is left side face. So for rest of the faces it is 0. So you will write it that this is the flux through the right surface E dot ds or plus flux through the left surface E dot ds and that will be equals to E is given to us, that is 2x. So 2x and the angle here is so try to do this question. So what is the value of 0 here? This is the origin. So at this point, what is the field at this point coming out? So it is in this direction. So what is the electric field at this point? So 2 into 0 is 0. So here it will be for the first phase, the x will be 0. So this is your origin 0, 0. So this x is equals to 0 here. So through the right hand surface, as x is 0, and through the left, what is the value of x? So x is equals to this is a, so x equals to a. So this is 2 into a I cap dot ds, and if you so this dot ds, now this can be written as, so this term is 0 plus this will be equal to the left face, it is so a dot b, magnitude of a into magnitude of b. So what is the magnitude of this side? This right hand is a into a square into cos. So this is the direction of this face and electric field, they are in same direction, so the angle is cos 0, and this will be equals to so I've taken the integration of this. So this integration is, I have taken its value, the area. So 2a was constant, it came outside, and then, so if you want to write one more step, so that will be equals to 2a is constant, will come outside, and this will be ds, and cos theta is also constant, so that is 0, so it will be outside. So and the integration of ds is a square. So this comes out to be, so the 2a cube. So 2a cube is the flux through the surface. So quite important question, sort of objective type question, but I have explained it to you. So you will have these kind of questions in your exams, and then you have applications of Gauss law. So students, you need to do the derivations related with the applications of Gauss law. So that's all for today. So these are the kind of CBSE questions from chapter 1, along with all the derivations that we have done till now. Thank you so much for watching this lecture.